You invest a huge amount in a machine that is extremely thin and very light. But to stay powered, you must carry this ugly, heavy, and very clunky plastic brick. It trips people over, gets incredibly hot, and takes up way too much desk space. Have you ever wondered why this chunky obstacle is still necessary in our wireless world? Today, we are opening the casing to reveal the complex power plant hidden right inside. The electricity inside your wall is a wild and chaotic force called alternating current power. It reverses its flow 60 times every second, creating a constant and very high-speed pulse. This wall power pushes with a massive pressure of 220 volts of energy. Your laptop, however, is a delicate digital ecosystem that requires a very gentle electrical touch. It needs direct current, a calm and steady stream flowing at only about 19 volts. Without that brick, the raw power would instantly vaporize your computer's expensive central processor unit. The black box exists to mediate this dangerous negotiation between the wall and your device. The process begins with 4 smart components called a bridge rectifier, acting like traffic guards. They catch the chaotic back and forth waves and force them in the same direction. Now the electricity flows one way, but it is still inconsistent and moves in jumps. This conversion creates friction, which is why your charger gets warm during its daily operation. Next, we find the capacitor, which looks like a small metallic storage tank for energy. It acts as a reservoir, filling during peaks and releasing energy during the low valleys. This smooths out the bumps, turning choppy electricity into a much safer and straighter line. When you see a spark, it is the capacitor suddenly drinking a lot of energy. But we still have 220 volts, which is far too much electrical pressure. In the old days, lowering voltage required massive iron coils that made chargers very heavy. Modern technology uses a clever trick called a switching mode power supply to save weight. Inside, a tiny transistor acts as a high-speed gatekeeper, flickering on and off very fast. It chops the smooth electricity into tiny pulses over 50,000 times every single second. This high frequency allows us to use a miniature transformer to shrink the voltage safely. By resizing the power thousands of times a second, we get the safe 19 volts. You might also notice a small cylinder on the wire, which is a ferrite bead. It acts as a magnetic filter, stopping electromagnetic noise from ruining your home Wi-Fi signal. This ensures that your other electronics nearby remain completely undisturbed by the high-speed power pulses. But we need safety. The board is split into 2 halves that never actually touch. To communicate across this gap, the charger uses an optocoupler, sending beams of pure light. If the voltage gets too high, the light tells the transistor to slow down immediately. This prevents the deadly high voltage from jumping across the gap and hitting your hands. Even the plastic casing is special, designed to be flame retardant and resist melting away. Some bricks are filled with special glue that pulls heat away from the delicate internal parts. It is an incredible city of bridges and reservoirs working tirelessly for your digital life. We often hate these heavy blocks, but they are our computer's ultimate personal bodyguards. From smartphones to massive gaming machines, power conversion is what makes our modern world. It is a masterpiece of engineering hidden in plain sight inside a simple black box. Now you know that every component has a specific job to keep you very safe. Even the smallest silicon chip plays a vital role in this grand electrical symphony tonight. Understanding the objects we use every day makes our entire world much more fascinating. If you found this useful, please hit the like button to support our science channel. Subscribe for more surprising histories of common things that you use in your daily life. Tell us in the comments which mysterious object we should open and explore next time. Engineering is everywhere around us, protecting our technology and our lives every single second.